There was a typo on my first board. It's supposed to be P inverse of y. It should be okay in your notes. Alright, so I want to solve for u equals P inverse of y. The reason why I wanted this u is if I look at what happens if I apply d to u, I'm going to get d, which is P inverse AP, and then I'll have P inverse y. That's why I needed the P inverse and not the P. These two would cancel. I get P inverse AY. And now since y is a solution for the differential equation, AY is just y prime. So I get P inverse y prime. P is just a bunch of constants, so it doesn't do anything to the derivative, so I can pull it in or pull it out. And so I'll get P inverse y prime. So I get u prime. So that means u prime equals du. So let me solve this. So now I can solve this system because it's nice and diagonal. D was 2, 0, 0, minus 3. Let me double check. D is, yeah. All right, so at this point we've done this before, but we get that if u is u1, u2, then u1 prime is 2u1, which means that u1 is c1 e to the 2x, and u2 prime is minus 3u2, which means that u2 is c2 e to the minus 3x. And so u is c1 e to the 2x, c2 e to the minus 3x. Solving for u isn't hard because this is a diagonal matrix. And so it's all down to the proposition that we use in the last example. And so the final step is to solve for y. But since u is P inverse y, that means that y is pu. Sorry. P was, I have it here, 1, 1, minus 1, 4, and then u is c1 e to the 2x, c2 e to the minus 3x. All I have to do is to multiply these two. I'll get c1 e to the 2x minus c2 e to the minus 3x. And then c1 e to the 2x plus 4 c2 e to the minus 3x. So we can now, depending on how the question was phrased, we could actually give an answer without vectors. The linear algebra is just a tool here. The question lives in a different world. And so this is what I get. Now, just for fun, let me check that this works. Let me just make sure I haven't skipped any parts. No. All right, so here, let me check that it works, that our method works. This is not something you need to do, but I think it's helpful once in a while to remember what these mean and just to double check that everything works. The first equation was y1 prime equals y1 plus y2. So let's check. y1, no vectors, sorry. y prime is 2c1 e2x plus minus c2 times minus 3 e to the minus 3x. So I get 2c1 plus 3c2. And now I want to check that it's equal to y1 plus y2. Again, sorry, I have a tendency to put vectors on top of these. No vectors here. So I want to check that this is y1 plus y2. y1 would be c1 minus c2, y2 would be c1, and so I'll get 2c1, that matches, plus 3c2 e to the minus 3x. That was the first of the two equations. I'll leave it up to you if you feel like it to check that the second one is satisfied as well. But I'm going to move on.